This is the fourth lesson from chapter 16, and this was the warm-up that we did for today's lesson. And today we're going to look at the inverse chain rule. So this you should recognise as a chain rule question, something in parentheses raised to a certain power. And we're going to actually do we're actually going to integrate this, but first of all we're going to look at what happens if we differentiate this. So when we differentiate this, we bring the power to the front and multiply. We then decrease this power by 1, and then we also times by the derivative of what's inside the parentheses. So the derivative of 4x plus 1 is 4. And then if we simplify, we end up with this. So what steps did we just take there? Well, we decrease the power by 1. We multiply by the old power. And we also multiply by the derivative of what's inside the parentheses. So if we integrate, we need to do the opposite of all those things. So instead of multiplying by the derivative, we're going to divide by the derivative. Instead of multiplying by the old power, we're going to divide by the new power. And instead of decreasing the power by 1, we're going to increase the power by 1. So we just got to remember the extra step. The extra step we're going to do for these questions is, because we did all this stuff before, increase the power by 1, divide by the new power, is this part. Instead of multiplying by the derivative, we've got to divide by the derivative of what's inside the parentheses. So, I claimed on the previous one that if we differentiate this, that we get to an answer of 12 times 4x plus 1 squared. So if we integrate this, then we should get back to this. So let's take a look and see if that's actually true. So, doing all those opposites, just to make sure we did this correct. We increase the power by 1, so we're going to make it cubed. We're going to divide by the new exponent, so we're going to divide by 3. And 12 divided by 3 is 4. And then we're also going to divide by the differential of what's inside the parentheses. So the differential of 4x plus 1 is 4. And then 4 over 4 cancels out. And we do indeed get back to 4x plus 1 cubed. But also we've got to remember to put a c on the end of the question. Now, questions can get a little more complicated than that as well. So if we were to have a question like this, then first of all we need to think about rewriting this expression. So we could write this as 6 times by 2x plus 1. As it's on the bottom of the fraction, that's going to be negative, and as it's a radical, we're going to make that to the power of 1/2. And then if we increase the power by 1, we're going to end up with a half. We have to divide by that new exponent, but we also have to divide by the derivative of what's inside the parentheses. So the derivative of 2x plus 1 is 2. And then if we simplify this, well, 2 times a half actually is just 1, 6 divided by 1 is just 6, so actually we would end up with that. Remember to check your answer if you want to. Go ahead and differentiate this and make sure you get back to what this answer is. And of course, as this is an integration question and this is an indefinite integral, we really should put plus c on the end of the question as well. To make these questions more difficult, we can also have limits on here as well, making them a definite integral, in which case you wouldn't need the c. So, that really concludes our lesson 4 from chapter 16. If you want to try some of the questions, these are the ones that I actually recommend. Exercise 16D, 1I through L, 2, 3, 5. 4's a little tricky, and we'll probably talk about that one in class a little bit.